Alright, trick class, let's look at how I can use the half angle formula for sine, how to use it, and then on the very next problem we actually are required to use the correct formula. So the half angle formula for sine. Sine is a 15, we're taking a 15-degree angle. That's an acute angle, so we would not have a negative out in front. So we know it's going to be either B or D, okay? And then the half angle formula for sine has subtraction underneath the square root. Half angle formula for cosine is the one with addition. So this would be cosine of half an angle. This is sine of half an angle because of the minus. So this is the one we want, B. All right, 15 is half of what angle is what is basically asking. So they're equal. So the sine of 15 is equal to the sine of something. And this something is a number divided by 2. Well, 15 is 30 divided by 2. All right, and so whatever we put here is also what we put here. So that's the way we would use that part of the answer box. And then once we've done that, we're supposed to find, okay, what is that? So we're taking the positive square root of 1 minus the cosine of 30 degrees. And then we are dividing that by 2 before we take the square root. All right, the cosine of 30 degrees, again, unit circle. 30 degrees is this first angle, this first special angle here. So the point is the square root of 3 over 2 and 1. Cosine is the x-coordinate. So cosine of 30 is the square root of 3 over 2. We're dividing that by 2. All right, getting a common denominator up top, I would have 2 over 2 minus the square root of 3 over 2. All right, and then these are a common denominator. So we can combine the numerators, but I'm going to go ahead and just combine that 2, that's the common denominator, with the overall denominator of 2. So when I simplify this, I'll have a 2 minus the square root of 3 over, and then these 2's up top, multiply by that 2 on the bottom, will be a 4. And then finally, square root of 4 is a perfect square, so I don't need a radical all the way extending down to the denominator. I can stop it right there, and then the square root of 4 is 2. So that's how I would write that expression. The square root of 2 minus the square root of 3, all under a radical. So I got a fraction, I got a square root, 2 minus, I got another square root of 3, and then on the bottom I've got a 2. So there's my half angle value for the sine function. Okay, so this is an expression that you're just going to have to be able to find. Your calculator is not going to be able to turn this into a fraction that you recognize. So you can't square it. You can't change it into a fraction with that math button. You're going to have to be able to do that math to be able to find some of these half angle formulas that have radicals within radicals. All right, let's try another one. Sine of 22.5. Same thing that we just did. All right, 22.5 is positive, so I need the positive square root. This is 1. Again, because it's sine, it's minus the cosine. We double this angle, so doubling 22.5 is 45 degrees over 2. All right, the cosine of 45 degrees is the square root of 2 over 2. And then divide that by 2. Getting a common denominator, 1 minus the square root of 2 over 2, that's going to be 2 2 halves minus the square root of 2 over 2. All right, and then again, same thing we did last time. Common denominator now. So that's going to come down, multiply by the 2. Underneath, up top, we got a 2 minus the square root of 2. All right, the common denominator 2 divided by the 2 that's there. Okay, so there was a yellow 2's that are common denominators, the green 2. Those combined to a 4. And then the square root of 4 is a perfect square. So we bring it out of the radical. We leave the 2 minus the square root of 2 under the radical. And that's going to be the form of our final answer. So again, fraction. We got a square root. We got a 2 minus. We got another square root of 2. On the bottom, we got 2. 2's all over the place here. So that's how we use that half angle formula for the sine function.